Hi everyone, welcome to the second week of this semester. The topics for today are syntax and semantics. We discussed this syntax and semantics briefly last week, but today we are gonna talk about that a lot. You already have the exercise number 1, which was out last week. As I told you multiple times, you'd better do that the sooner than the later, because it is highly likely that you are going to have that in the midterm exam. We are not yet sure about our midterm format because we have been discussing, and we are still discussing, what are going to be the best way for the students to learn the material. But it's really highly likely that you guys are going to have online coding for the midterm exam. Then you'd better start earlier for this exercise. And if you have looked at the exercise, then this slide would make sense. If you haven't done that, this slide may not make any sense. So this is kind of a litmus paper to see that whether you are ready for this course for the remaining semester. Do not import any other libraries than the libraries that the exercise told you to use. Do not use the break statement. You are supposed to use functional programming, not imperative programming. Do not use the while and for loops. And I know that the head TA, Jamin, explained that last Wednesday. If you do not get it yet, then go back to the lecture. Do not use mutation. Again, I know that Jamin explained the beauty and good things about immutability last Wednesday. Questions and answers. There are several questions about the pattern matching we learned last week. Let's review this syntax. DEF is the keyword explaining that we are defining a function. ... It could be some function name which has one parameter. The parameter name is expert, whose type is, again, expert, large expert. And it's going to return something depending on what you do with the argument. And it says, hey, depending on the value of this parameter expert, match the value with 3 cases. How did you know that there are only 3 cases? Because that's how you define this type called expert. When you define the type expert, there were only 3 cases, num, add, and sub. And you should know that num takes only one field, which is an integer. And you should also know that add and sub, they take 2 arguments, 2 fields, and the types of those fields are expert. Is num, this num, a constructor or a type? Is match, this match, a function or not, or what? How is match different from if and switch statements? Why is expert that left the num on error? We discussed all that last Wednesday, but we are going to review that briefly before diving into the new concepts that we're going to learn today. What is a num? It is a constructor. What is a constructor? If you don't know the word, you need to go back to the last week's slide and not the last week's lecture, which is going to be available only for a week from that day. It is a constructor. A constructor is a function that constructs an object. This arrow, 화살표, this arrow means that it's a function type. A constructor is a function which takes an integer, produces an expert for this num case, meaning that num is a constructor which takes an integer and produces an expert. At the same time, it is a type. It is a type which is a subtype of another type called expert, meaning that there could be a type AE, or this should be expert. And then this expert has 3 subcases. add, sub, and num. And we say that expert is a supertype. And these three, add, sub, and num, are subtypes of expert. And we write that with this notation. So num is a constructor which takes an integer. When it takes an integer, it creates an object of type num, which is a subtype of another type expert. And in this course, till the last lecture, which is going to talk about subtyping altogether, we are not going to use the type num for this one, and we are going to consider that as expert. Pattern matching, that's another new thing that we learned last Wednesday. Let's look at this function named interp, which takes again one parameter of type expert. It produces a value of type int. What does it do? It gets the value of this parameter and then check whether this expert's value is num or add or sub. Depending on that, it performs appropriate actions. So does it look like something familiar to you? Like this. It asks like, hey, you expert, are you an instance of num? Oh yeah, then I'm gonna make you as an instance of num. Then I know that num has one field of name n. Are you an instance of add? Oh yeah, then I'm gonna treat you as an instance of add, and then I'm gonna call it add. Then I know that you have two fields, left and right, of type expert, both of them, like that. So you can do that, meaning that you can perform this pattern matching with very small number of lines and clear matching of the values with these shapes. Or you can do this if then else nested checking and asking your type and so on. So this one may be more familiar to you, but it's really long and tedious, and it's really easy to make errors. We call these things like error prone, meaning that it's really easy to make you introduce errors because you may miss some case, you may miss some names and things like that. But the previous version is really nice and clean. If you don't see the benefit of using pattern matching yet, then you'd better do exercise 2 and 3 and more, and because those functions are going to be getting longer and you're going to use many if then else's. If you are not using pattern matching, then you're going to see the benefit of using pattern matching. In type checking, we describe that these are concurrent syntax. Expert is a set of expressions, and there are 3 ways to make an expression. Either number, pick a number from the set called num, or make an expression by using open, close, and plus with 2 expressions, or using open, close, and minus with 2 expressions. These are concurrent syntax, and we can represent that in Scala like this, saying that we are defining a set of expressions. We do that by writing trait, by defining a type named expert. And then we make 3 cases for expert. They should be declared by using case class and with their names. That's all we learned last Wednesday. We do not want to go into the details one more time, but let's review one more time that by having that, you can make an addition by using a constructor named add, which has 2 arguments. Then expert Yeah, it's add. We know that. And we know that add has two fields. But all we know about the first field named left is that its type is expert. We do not see its value. At type checking time, we do not see the value. We just see the type annotation. If you do not get it yet, don't panic. We are going to talk about types a lot after the midterm exam. Until then, you do not need to worry about type checking. Programming language. A programming language is defined by syntax and semantics. Syntax is how it looks like. Semantics is how it behaves. Again, we discussed this last Wednesday. And arithmetic expressions may look different for different languages. So whether we use open, close parentheses, whether we put addition and subtraction in the middle of operands, they are all about concrete syntax. Concrete, the real thing. How you write it. You may want to write open, close, two operands and operator in the middle. You may want to write two sub-expressions, three and another expression, and then operator in the middle. Two sub-expression, operator in the middle, like that. Because that's our concrete syntax here. But there could be different kinds of concrete syntax. Look at this. We are defining a set of expressions. The first way to make an expression is to pick a number. The second way is to make an addition. The third way is to make a subtraction. So far, so good? Yeah, they look good, except that something is different. Concrete syntax 1 uses open, close parentheses. Concrete syntax 2 uses open, close, curly braces. 중괄호. The concrete syntax 1 uses infix operator, meaning operators are in the middle of two sub-expressions. Concrete syntax 2 uses a prefix operator, right? Operators come front of operands. So they look different, but they denote the same thing. Even though you say open parentheses 4 plus 2 close, and even though you say open curly brace plus 4 2 close curly brace, you all know that they represent the same thing, right? Either this or that, they represent addition of two numbers. And the first number is 4 and the second number is 2. Even though they look slightly different, they have the common structure. 겉보기엔 좀 다른 것 같은데 실제로 똑같은 걸 나타내요, right? You see the similarity. So, in this case, whether we use open parenthesis and close parenthesis, or open curly brace and close curly brace, whether we put operators in the middle or up front, they are all about concrete syntax. Visual clutter. Visually showing you some differences, but actually what they mean, what they denote, is the same. And we call that abstract syntax. Compared to concrete syntax, what that actually denote, we call abstract syntax. So we can represent this concrete syntax using this Scala abstract syntax. Do you see that? So we can make this addition of two expressions. In this first line, the first expression is a number, the second expression is another number. In this second addition, the first expression is a number and the second expression is a subtraction. Because num takes only 1 int, this num takes only 1 int. Because sub takes two expressions. It takes two expressions. They happen to be two numbers. So far so good? So what we just said is that when we denote addition of 4 and 2, that's what we mean, what we want to represent in our mind. And how would you represent that to a computer? How would you want to write that down on a paper using pencil? You may want to use this syntax or that syntax. That's called concurrent syntax. Which way you prefer? What they actually represent is abstract syntax, and we can represent that using Scala implementation. Okay? So we are using this expert and AE interchangeably, and I'm gonna fix that in the slides. So when you listen to this lecture on Monday, the slides you can download from the website are gonna be what? Expert. Okay. Then parsers. What is a parser? So, in this semester, there are CS320, CS420, and either this semester or next semester, they're going to be CS520. So as you may know by now, these twos meaning programming languages. And CS320, that's programming language course that you are listening to right now. And CS420 is a compiler by Professor Ji-hoon Kang. If you are interested in programming languages, and if you find this course interesting until the end of this semester, then I strongly recommend you to take this course. It's really good. In CS520, it's a programming language course for graduate students, but you don't need to be scared of the course because, if you, again, find this course is interesting until the end of this semester, then you are ready to take this course. So until last semester, I recommended to take this course after CS320 because CS420 was not really available for some time. But now that we have Professor Ji-hoon Kang is teaching CS420, I strongly recommend you to take this way. Okay, then what's a parser? And why did I tell you about compiler with this parser thingy? That's because compiler takes a program and produces another program. If you remember, we discussed the differences between compiler and an interpreter. And what is a parser? Parser is a program. It's a program which takes some program and produces its abstract syntax tree. And we call this program P is written in concrete syntax. And this abstract syntax tree, that stands for what? Abstract syntax tree. Oh yeah, so you see that this concrete syntax is a sequence of characters. And the parser takes a sequence of characters and then tries to understand what's going on and represents a tree structure. Just like you saw before, when we pass open 4 plus 2 to this parser, then it's gonna produce what? Addition of two numbers whose values are 4 and 2. That's a parser. And for AE, for our language named AE, we say that, oh yeah, it's gonna be what? It's gonna be a parser for expressions with 3 cases. The first one is an integer. If you write an integer, then it's gonna convert that to num n. when the next thing, wrap meaning open and close. When you have open and close, which has an expression followed by plus, followed by another expression, then it's gonna construct add. Ooh, isn't it cool? When you have an expression followed by minus, with open and close, of course, and then another expression, it's gonna construct sub, and like that. It looks a bit complex. It's not really, but don't worry. We are not gonna ask you to write parsers in this semester. For any expressions, for any languages that you are gonna implement their interpreters, we are gonna give you parsers. So here, int receives an integer value. This denotes concatenation, and this denotes ignoring without receiving the value of the right-hand side. Wrap enclosed by open and close like that. Again, you don't need to understand every single line because we're going to produce that. We're going to give that to you later. But all you need to know is that because this parser is written that way, when you say, hey, AE, please parse this one 3. Please parse this one 3 plus 4. Like that. Please parse this one. Then it's gonna give you perfectly good looking ASTs. You write it down. That's an exercise for you. What's gonna be the result? What's gonna be the result? Yeah, you do that. How about this one? Open 5 minus 1 and another minus. This should be a parsing error because we do not have a rule for that. Then the parser will say bad syntax error. Right? So if you want to know how that works, really, then you'd better implement this. You'd better do exercise on time, on schedule. Okay? So again, it's another summary for that. Concrete syntax 1, concrete syntax 2, they may look different, but they represent the same thing. And what I just said is that those concrete syntax can be parsed to abstract syntax. Okay? So you should be able to understand those connections. And interpreter now represents semantics. Until now, we talked about how to write code. And now we are going to say how to understand what that means, how that behaves. First way is to implement interpreter, like just we did last Wednesday. And now when you have this parser and an interpreter at the same time, it's really cool. You can just write some expression in concrete syntax and pass that to this parser, AE. Then what does it return? Remember, this parser takes a string and represents these AE, abstract syntax. So here, when we have this string and pass that to a parser, it's going to give us AST type expr. And because this inter function takes an expr, produces an integer, this is gonna produce an integer. And that should be 3 minus 4 plus 7, which is 6. So all you can do is what? Oh, you can give some expression in the concrete syntax of that language, pass that to this parser AE, which is gonna give you an expr. Then you can pass that expr to this inter function, which it takes and produces an integer, and you can test your implementation, the result of this inter function with the expected value 7. Now let's take a quick break. Again, geese, now they are coming back from the, parking lot of computer science building to the pond. It's actually in front of that building, KI building. It's raining and they're walking in a row.